Welcome to the 5.2 instructional video. What we're going to be talking about here is how we apply our transformations onto the graph of y equals sine x. And we are going to be doing the same four transformations. I'm going to put that general form above what we talked about in chapters 1 and 2 and 3, I guess, for that matter, except we're going to be applying this specifically to our sine and cos functions from that. For some reason, though, they decided, and there is a reason because we have little formulas for them, that instead of h, what we're going to end up using is c, and instead of k, we're going to be using d. And what that allows us to do is write these equations that allow us to examine a graph and determine a, b, and d directly from the information on the graph. Now, what that looks like when I apply it to my sine function is the vertical stretch is going to be multiplied onto the outside of sine, and then on the inside of that trig function is now b times x minus, and I know it's a little frustrating, but again, we are just using c instead of h. They are in the same position relatively, and then at the end, we would add d. Now, this doesn't look any different if you're using cosine. Cosine would be y equals a times the cos of b times x minus c, and then plus d. And a little later, we'll learn about tangent and some of the limited transformations we have to do. The best thing I think as soon as we talk about this is to give those equations on how we can determine a, b, and d from information on the graph. Our a value is equal to the maximum y value minus the minimum y value divided by 2, whereas our d parameter is the maximum value plus the minimum value divided by 2. I always like pointing out that this is essentially what we call the average value. And there'll be a couple other terminologies that I'll show in the next slide. The other one, I guess maybe not the last one, that b, or I should put the absolute value of b, is equal to 2 pi divided by the period, or if it's in degrees, 360 degrees divided by the period. Now, period can not be negative, so I suppose I don't really need the absolute value there, but that is just a manipulation of the formula we looked at in 5.1, which was that if we do apply a b, then the period of my new function is 2 pi divided by the absolute value of b. And these are just manipulated versions of one another. Now, there is one that hopefully you noticed I didn't have, which was the c. C is a bummer. It's a lot harder, and all I'm going to write is that we are going to determine it via inspection, which students do not like typically. It does require a fair amount of mastery as to the shape of y equals sine x and y equals cos x. Now, just a couple little terminologies. This vertical displacement is the d value in that transformation form that I wrote on the previous page, and this phase shift is the c value. Now you can see that they actually write the terminology. The d is the vertical translation, so that's going to move our graph up or down, keeping in mind that that's a vertical translation in our function form. That makes sense. And c is the horizontal translation. And those are translations because in d's case, it's added to the outside of the function, and in c's case, it's added directly on to that x variable.